Hey, thanks, Sarah. So as she said, today we're going to be covering what's new in NERC session. I know that we've had many other team members cover a plethora of things regarding NERC and compliance. So we'll be touching on and then diving deeper in some of these topics, as well as our lessons learned and frequently asked questions. Go ahead and get us started. We'll be looking at our agenda here. Starting with our introductions in a moment, and then I will walk us through a new standard EOP 12 that recently went into effect, cover the new GO IBR initiative and some compliance lessons learned, and then I'll pass it off to Ben to cover some of our engineering best practices and lessons learned as well. And then we'll leave some room at the end to go through some questions and answers. All right, so hi, my name is Kaylie Hague. For experience, I started in Nevada Irrigation District in Northern California as a hydroelectric intern, assisted their team with all kinds of compliance related things outside of NERC and within NERC. And then I transitioned to a NERC focused role as a compliance technician. And then I ended up moving and joined GridSME as a compliance analyst. And now my current role here is a compliance implementation lead. So I put together low impact GO and GOP programs and take clients through the registration process with regions and ensure that they have a compliance program up to COD, and then I pass them off to an account manager who makes sure they stay compliant post COD. And then I will let Ben introduce himself.
Hi, everyone. Good afternoon. Thanks for joining us for this session. Ben Smith here with GridSME. I serve as Director of Engineering for implementation projects. Most of my time spent here has been working with generator owners on the development and implementation of their NERC GEO programs, mostly centered around the engineering side of things with our team of SMEs that put together the technical efforts. And been in this role here for about 2 years. I was brought into GridSME as a project manager for our regulatory compliance group, and worked there for about a year before moving into this role. And yeah, glad to be here and working with folks like yourselves on these sorts of efforts. I came into GridSME with about 13 years of commercial real estate development experience. So mainly portfolio management, asset management, construction, project engineering, and project coordination there. And I do have a lead accredited accreditation I gathered through real estate, but has a lot to do with sustainability, so it's proven to be somewhat applicable here. Glad to be here and look forward to covering content with you today.
All right, thanks, Ben. So as mentioned, we are going to start with EOP 12, which is a new standard that went in effect earlier this year. And just like all of our good standards, they come with good cause and due to an event. So I'll walk us through the history, how we got here, what the impacts looked like to the grid, what the impacts now look like for you as a GO or GOP. And then we'll take a deeper dive into what the requirement actually is asking for and how you can ensure compliance. All right, so back in 2018, a large area of the South Central region of the United States, that you can see here on this map, experienced unusually cold weather known as a cold snap or a polar vortex. And this cold weather really led to some serious impacts that would ultimately influence the development of EOP 11 and 12. Please note that we're talking about EOP 12 today as applicable to GOs and GOPs, but know that EOP 11 is also out there and is applicable to your BA, TO, TOP, RC, DP, a bunch of acronyms for you. And EOP 11 was originally applicable to GO and GOP, but it's a phased process. So the focus is now EOP 12 for you guys. But back to 2018, during the cold snap, there were 183 individual generating units that experienced either an outage, a derate, or a failure to start between January 15th and 19th. And approximately 14,000 megawatts of generation experienced an outage, derate, or failure, including generation that was already on either planned or unplanned outages. So by the morning of January 17th, there was over 30,000 megawatts of generation unavailable during peak hours. And really what that meant is that consumers didn't have access to heat or electricity during this extremely cold weather. At the end of the day, there really just was insufficient reserves to balance generation and load, and that caused MISO to have to declare an energy emergency, and other states like Minnesota and Wisconsin actually had to shed load and send it to Texas in order to prevent the grid from going black. On top of that, there was also a lot of freezing going on, and that impacted gas reserves and access, including blocked pipes, and it caused the pricing to surge for heat and gas. So because of all the impacts and what happened to the grid during this cold snap, FERC and NERC completed a study, and what they found was 30% of the problems were caused by the weather, including natural gas supply cuts to gas-fired generators and equipment breakdowns that were due to cold temperatures. The GOs and GOPs directly attributed 14% of the generator failure to weather-related causes. So that would be frozen sensing lines, frozen equipment, water lines, valves, and the like. And when they looked at those GOs and GOPs, they found that 1/3 of them did not have a winter weatherization plan. And so the idea here being that if they had a plan, maybe we could have prevented some of this. And from that came EOP 11 and 12. Okay, so the key requirements within EOP 12, if we were to look at that standard, breaks down into 4 sections here today. Starting at the top, it's going to require you to have a cold weather preparedness plan. And that should detail how you'll be protecting your generating units from freezing conditions. And you'll want to include your freeze protection measures and operating limits based specifically on your unit temperature ratings. The second item here goes a little bit deeper into that temperature data limits. So you do need to establish your ambient temperature thresholds where cold weather protections or procedures will apply, and report your temperature-based limitations to your RC and TOP as applicable. From there, you'll want to conduct annual training and awareness. So all staff should be aware of your facility-specific cold weather procedures, and that should be completed annually as a training, but also you need to complete your cold weather inspection to ensure that you are prepared for emergency operations related to cold weather events. And then the last one here is going to be event reporting and corrective action. So if you're impacted by a cold weather event, you need to report the event and conduct a corrective action plan to prevent reoccurrence and grow through it better. Next, we'll take a look a little bit deeper into the actual plan itself. So on the screen here, you'll see R4, and that is going to be the actual requirement that has you developing a preparedness plan. And really the goal of R4 here is to ensure that you have a robust plan to maintain operation reliability during cold weather events. So what do you need in order to have a robust plan? Well, 4.1, they want you to have a calculated extreme cold weather temperature, or ECWT. And this value is going to represent the lowest temperature that your generating unit is expected to encounter, and that's based geographically. And it must be able to withstand that temperature. So this really is meant to help guide you through your design and operational decisions for cold weather readiness. You might want to consider insulation or heating systems. And it's really important to know here that this ECWT is going to be built off of accurate meteorological data and historical trends. And so this could change in the future depending on the history of the area, and we'll talk about that in a second as well. 4.2 is going to be your generating unit cold weather data. So this data should capture specific information on how your unit performs under low temperatures, your startup times, your limitations, and this data will provide the foundation for identifying vulnerabilities and guiding operational strategies. And keep in mind that this will require future updates and analysis. So maintaining good record keeping and data sharing across departments will improve your process to updating your plans or any limitations that may come up in the future based on your historical operation or historical weather trends in your area. Taking one step forward to 4.3, we have our identification of cold weather critical components. So you'll want to identify components that allow you for targeted inspections and mitigations to reduce failure risks. And a cold weather critical component is really going to be a component system or fixed fuel supply under your control that could be susceptible to freezing. And if it did freeze, could lead to a cold weather event for your facility. That is going to exclude any equipment housed within heated structures that maintain temperatures above 32 degrees Fahrenheit. So the rationale really behind this definition is to identify critical assets that require specific cold weather protections to ensure operational continuity in extreme conditions. And also be sure to collaborate with your engineers and technicians for the site. They'll know your equipment best, they'll know what falls into this category of critical components, and they'll help you establish an inspection list to conduct annually and prior to cold weather events. All right, then looking at 4.4, you'll want to document your freeze protection measures. So after you identify your critical components, you want to look at your insulation, heat tracing, or temperature monitoring systems and ensure that their proper freeze protection is ensuring the essential systems continue to function during any cold events. And the last one here is going to be 4.5, your annual inspection and maintenance, which we've already touched on a little bit, but this is required and will ensure the operational functions of your facility and also guarantee, hopefully, that you're ready for winter and should verify that all your protections are good and you don't have any degraded components. And if you do, then you get them on the list for repair or replacement prior to a cold weather event occurring. All right, now we'll take a closer look at what the EOP 12 temperature data is going to consist of. So I mentioned before that this information could change. So prior to COD, the calculations might be one way. You have a very extreme cold weather event that could change your limitations and the historical data that's impacting your ECWT. So R1 also requires that at least once every 5 calendar years, you are calculating that ECWT. And that means identifying the source of your data and also capturing the date that you calculated that data. You'll want to identify your operating limitations in cold weather, and you'll want to identify your generating units minimums. So we'll be looking at your design temperature, what is the minimum the unit was built for. We'll be looking at the historical operating temperature, the coldest that it's ever run for at least 1 hour. And then the current performance temperature, this would be performed during an engineering analysis, and it would reflect the unit's present capabilities. Okay, so in summary, EOP 12 came into effect to protect the grid and the units, make sure everything is operating in a reliable manner in an extreme cold weather event to really avoid system failures It does require you to develop a cold weather plan, identify your critical components, and implement any freeze protection measures, including performing annual inspections and training. Really emphasizing here that it's about proactive planning, using engineering analysis, historical data, your operational limits, and to mitigate any risk associated with a cold weather event that could happen in your area and ultimately prevent a blackout or widespread grid imbalance. Before I move on to GO IBR, does anyone have any EOP 12 related questions? Keep in mind, we can also have questions at the end.
I don't see any questions coming in, but if you type them in, we'll get to them as soon as we can.
Perfect. Thanks, Sarah. So the next hot item that I wanted to talk about today was GO IBR. So I'm going to walk everyone through what IBR is, what are the historical trends we're seeing here, and the risks associated with the grid. And then what does that mean for you? What is registration and impacts going to look like, and what should you be aware of and planning for? So what is IBR? Well, the definition from NERC is electricity generation or storage technologies that use power electronic devices such as inverters to convert direct current to alternating current for connection to the grid. So this is going to include our solar PV, wind, BESS, or hybrid. And essentially IBRs, such as those we just talked about, they're increasingly replacing what we would consider traditional generation or synchronous generation. And if we look at thermal and hydro, they're primarily based on physical design of a generator, but the behavior of an IBR is primarily driven by power electronic controls, which provides a higher degree of flexibility, but also a higher electrical complexity. So understanding the inverter interactions among other inverters and with other grid components is going to be important to maintaining a reliable grid. So if we were to look at the historical trends, including current and future projections, I created this timeline here, and essentially starting on the left, from 2000 to 2010, the United States averaged between 500 and 1,000 new transmission interconnection requests per year. And that's around 150 to 200 gigawatts per year of proposed generation. Then if we look at proposed capacity for the next decade, 2010 to 2020, those new requests rose significantly to 2,500 to around 3,000 requests per year, which represents anywhere from 400 to 750 gigawatts per year of proposed capacity. So this is a 3 to 5 time expansion compared to the prior decade. And all this good information is available on the DOE site if you're ever so inclined to look into the stats. But as we move forward to the green section here, 2015 to 2022, NERC released the long-term reliability assessments, and they reported that the U.S. had retired over 45 gigawatts of coal and gas generation. So again, that's the synchronous generation I mentioned in the last slide. And if we look at that a little bit deeper, that is about 11 gigawatts per year for 12 years, which is pretty incredible. Looking a step further, if we are predicting trends, they anticipate over 50% of new capacity between 2023 and 2030 will come from solar, wind, and storage facilities. In 2023 alone, solar and wind accounted for 25 gigawatts of new capacity. And looking even further ahead, by 2030, nearly 70% of the US grid capacity could come from non-synchronous resources, which raises concerns about adequacy of system stability without synchronous inertia. The shift really from traditional generation to our IBRs is reflecting a really large concern to integrate IBRs with the BESS while still maintaining system reliability. So why should we be concerned about all of the IBR that is being connected or that has been connected and is not registered? Well, historically, the goal for connecting wind and solar with inverters was primarily just delivering power to the grid. Consequently, grid operators have generally been allowed or even required to disconnect the IBR facilities during times of grid disturbances. And then once everything was cleared, they were allowed to reconnect. This approach minimized IBR interactions with the grid and maintained system reliability when IBR capacities were low. But given the growing capacity of IBRs on the grid, these generation sources increasingly need to ride through disturbances. Other way to say that is they need to stay connected and support grid recovery. Today, the requirements for ride-through are not really included, and there are not specific performance specifications out there for IBR. And in general, there are very limited interconnection requirements associated with these IBRs, apart from high-level requirements that were introduced by FERC and NERC. And additionally, in recent years, there have been a series of disturbance events involving IBR disconnections. There was a study done on these recent disconnections, and 135 of the performance issues were not identified during interconnection studies of the involved plants. So NERC's event analysis of these events identified several gaps related to IBR interconnection standards, including their conformity assessments, modeling capacities, validation, and verification. So knowing all this, looking at the trends, looking at the concerns and reliability of the grid, came FERC Order 901. There we go. And FERC Order 901 really directed NERC to update reliability standards and address IBRs in 4 areas: data sharing, model validation, planning and operational studies, and performance requirements. In response to the FERC Order 901, NERC released these milestones in how they plan to address the concerns in this phased implementation, if you will. So phase 1, from May 2023 to May 2024, NERC was going to complete the rules of procedure revisions and approvals, and they were going to commence Category 2 GO and GOP candidate outreach and education. And I'll walk us through the categories in one moment here. Phase 2, from May of 2024 to 2025, the goal was to complete the identification of those Category 2 candidates and continue in outreach and education regarding the IBR initiative. And then phase 3, from May 2025 to 2026, they want to complete registration of Category 2 GO and GOP candidates, and thereafter would be subject to applicable NERC reliability standards and continue the outreach and education to those GOs and GOPs. So with this launch, you'll see a lot of reference to Category 1 and 2. So I thought I would just break it down here. Category 1 is what I like to consider the old threshold for registration. So this is where we have current registered IBRs, and the NERC threshold that they're meeting is going to be that 75 MVA rating and interconnected at 100 kV or higher. This comes from the Bright Line rule, which excluded many smaller IBRs from mandatory registration. Now, if we were to look at Category 2, This is where we're going to be identifying IBRs that are already running today and are not registered or are going to COD in the future, and their aggregate nameplate capacities are going to be between 20 MVA and 75 MVA and interconnected at 60 kV or higher. So historically, they weren't required to register. They would disconnect if there were disturbances. And now we're looking at getting them registered, having them complete ride-through modeling, validation, and getting them up to date and compliant with NERC standards. Important to note, though, that we haven't seen a complete list of the standards that will be applicable for the GO IBR. I was looking yesterday and they're hoping to have those finalized and out by November 4th. So just around the corner here, but we do not have a set list of applicable standards yet. Okay. So what does this all mean for you? Starting at the top, you will need to coordinate with your applicable region to complete your registration process, and ultimately you'll be submitting data submittals, just defining your roles and responsibilities, and creating a NERC portal account in order to track your site. You'll need to develop a compliance program for your facility to ensure that you comply with all of the applicable standards that I was just mentioning. And eventually you'll need to submit modeling and operational data for integration, including ride-through capabilities, fault performance, and monitoring. Potentially, you'll need to enhance your cybersecurity protocols. We don't know exactly the extent of those yet. However, we can look at CIP 3.8 and get a good idea of what you might be expected to do. Existing units may also need to undergo equipment upgrades or testing to meet fault ride-through voltage regulation and frequency response requirements. And the last one here is going to be engagement with NERC, so potentially completing self-certification or audits that may be required to ensure compliance with critical standards. All right, and I know we talked about the timeline for NERC rolling out their implementation, but what does the timeline look like for our GOs and GOPs that are not yet connected to the grid and can anticipate being a part of this IBR registration? Well, about 12 to 18 months prior to COD, you should be assessing whether your facility meets this new Category 2 threshold. If you're unsure, definitely reach out to the region, contact a consultant, get someone to look at it and ensure early whether you need to be a part of this or not. You also may need to consult with your TOPs or PCs potentially. You'll also begin the NERC registration process. So after reaching out to your regional entity, you'll start getting them some information, they'll have some questions, and they'll really get you a better timeline for what they expect with registering. About 6 to 12 months before COD, you will be submitting your NERC registration package. So they'll be looking for details such as your ownership, your point of interconnection, and your aggregate capacity. And then you'll probably be coordinating with the NERC compliance team at this point to ensure that all of your filings are in good order and that you can begin developing your NERC compliance program and ensure that you are compliant. About 3 to 6 months before COD, you should be finalizing your compliance program, implementing your procedures and controls for real-time operations, completing testing and training for your staff so everybody is up to date and aware of all of these standards and especially those time-sensitive tasks that might come up. At COD and beyond, you are going to begin maintaining records, submitting reports, and really being prepared for any post-COD audits. You'll also want to stay up to date on any NERC alerts and especially anything that is new IBR related standards or guidance. All right, so in summary here, IBRs are really introducing a lot to the grid that we have not historically seen, largely due to their power electronic interface and becoming more and more popular as we see synchronous generation being retired. Due to that growth and lack of visibility, NERC is aiming to register and monitor IBRs that meet that 20 MVA threshold to ensure that we don't undermine the system stability, visibility, or ultimately the reliability. That new registration requirement is going to ensure that existing and future small IBR units contribute to the reliability, improve visibility and operational coordination, and really should be capturing previously unmonitored units and promoting proactive compliance with NERC standards. This expanded oversight also just reflects the NERC and FERC's commitment to grid reliability in a high IBR environment, whether small scale solar farms or aggregate BESS, they should align with the evolving needs of the local electric system. All right. I move on to some lessons learned. Any questions about the GO IBR initiative?
Here is a question. Is registration required by May 2025, or is that when the registration requirements begin?
So if you are an existing GO IBR facility that is already running, you should have your facility registered by May 2025. However, there is going to be a grace period, and if your facility is coming on after that, it's really going to be a case-by-case basis from what we see, and then they'll expect full compliance by May 2026. We should be getting more guidance on what that grace period is going to look like and what really the cutoffs are for the various GO IBR facilities. All right. Next, I'll move on to some frequently asked questions and some good lessons learned, starting with some definitions, COD implications, and then ongoing best practices. All right, so what is COD? We get this question a lot. We see it get confused a lot. It's really common, especially when we have so many different entities having their own definitions. And so I just wanted to lay out here what we can expect these CODs to be defined as. And I also put them in order of what we would typically expect them to occur, keeping in mind that every facility is unique and the timelines are always variable given many different factors. So starting at the top here, equipment. So this would be the date that your equipment is installed and approved for operation. This must happen first to ensure individual components are functional for system commissioning. So this is really the first COD that I would expect to hear associated with a facility. The next is going to be your EPC, which is when your contractor hands over the project, or what we would hear people refer to as physical completion. This is going to ensure your project is complete and it's been handed over to the owner. Next is your ISO. This is going to be full integration and operation with the market is approved. This is typically at the discretion of the ISO. You don't have a ton of influence over, though you can backdate. I know Kelsey spoke earlier this week about that. And really, this is just going to validate the project's readiness to connect to the grid and operate in the market. Then you'll have your PPA COD, which is the date you must begin selling power to your off-taker. And it's going to activate the revenue stream by enabling energy delivery under the agreed contract. Your ISO and PPA happen very close together, if not at the same time, though I've seen it occur in multiple different ways, depending on what your contract says. And so you really have to just pay attention to what your stipulations are and when you can and cannot begin selling power. The last one here is going to be NERC COD, which at GridSME we've started referring to as the NERC registration date instead to avoid confusion. But this is going to be the date of compliance with NERC. And this really has to happen last because they're going to assume and require that you're compliant with your ISO and everything else first anyways. So that really should happen last. The other question I get all the time is, can we just go through with NERC registration, get it off our list, say we're compliant, get our NCR number? The answer is no. It is not recommended because the day that you declare COD with NERC, or your NERC registration date, is the day that you are going to be expected to be 100% compliant with all applicable standards. So if you are trying to declare your NERC COD, but your EPC hasn't handed it over yet, that likely means you're still going through testing and commissioning, and your NERC date is assuming you're done with that. Another thing to consider here, we'll back up one more step. If you're still doing testing and commissioning, things could change. And so what you've completed for NERC evidence might not even be accurate anymore. So it's important to wait, have all your documentation and evidence accurate, and then declare NERC COD. Okay. On top of that, when you declare NERC COD, I like to say you're starting a timer. So there are all kinds of things that you need to take care of post COD. And if you start that timer early, you are essentially signing yourself up to complete some testing earlier, complete your monthly reportings earlier, completing your battery testing earlier, monitoring your relays, all kinds of good stuff that I just would recommend that you avoid, and wait until everything is beautifully declared COD, and then go ahead and register with NERC. Another confusing piece here is the day of COD, you do not have an NCR, which is going to be that NERC registration number you get assigned. We oftentimes see third-party or investment companies asking for your NCR because you're registered, and it just doesn't work like that. NERC's process is a little backwards, and so what happens is you go through the process, you hit submit on COD. It goes through your region for review for about 30 days. Once they approve it, it goes to NERC for another review. Potentially could go back to the region for more questions, which could potentially go back to you for more questions, and then it goes through that whole process again. More often than not, I see an NCR assigned about 60 days after COD. All right. So now knowing all that, how do we actually know when NERC COD happens? So I pulled this from NERC's registration guide, and essentially the way they define their COD is after which all initial testing and commissioning has been completed, and the initiation date on which the GO and GOP can start producing electricity for sale. My favorite piece here that I love to show and explain to people is this footnote 5 here, which I will pull up next. And that footnote is going to say this excludes the sale of test power during initial testing. So oftentimes people think that because they're generating power, they're going to sell it, that they should be registered. That's not true. They understand that you are going to be generating power or taking power off the grid in order to perform required testing to ensure compliance. And you can sell that power even though you're not registered and 100% compliant. And that would be considered the sale of test power. Once you've finished your initial testing and commissioning and your GOP is taken over, that is when you are now going to be selling commercial power. And that's because your PPA is activated, your ISO has declared COD, really everything is clean, packaged, and ready for the market. And so that is when we would go ahead and recommend you declare COD. All right, some of the last little GOP lessons learned that I'm going to cover today are some pretty simple ones, but very important. Starting at the top, your roles and responsibilities. If you're going to be a GOP, it's really critical to understand what your roles are, what your third-party roles are, and even what your roles are inside your own company, right? So who's ensuring compliance, who's completing reporting. There's a lot of time-sensitive standards out there. Who has their eyes on that and is going to be responsible? Which kicks me into the next one here, effective evidence retention. Where are you keeping it? How are you keeping it? And for how long? If an audit is to occur or when it occurs, do you have easy access? Do you know where your documentation is and is it in good order? All very important things to consider when setting up your GO and GOP program. And then the last more obvious item here is your post-COD tracking. So after COD, there's a plethora of things that you'll want to keep your eyes on and coordinate with the appropriate SMEs as needed, including your mod testing, battery testing, cybersecurity awareness, NERC alerts, all that good stuff. I know there's plenty of other lessons learned too, but I will go ahead and pass it off to Ben. Feel free to drop any questions for me in the chat and we can cover them at the end here.
All right, thank you, Kaylie. Sarah, let us know if there's any questions in the chat in between. Happy to pause and any content that I'm going to cover. And let's see if I can navigate this as well as others have before me. Okay, so yeah, we're at the end of the week as far as the training sessions that we had. I know if you've sat through any of the other trainings that GridSME's hosted, new resource implementation, engineering interconnection, GO and GOP guidance, NERC 101, etc. There might be some redundant things that we've covered. Thanks for bearing with us through that. What I'm going to try to cover here is just some high-level best practices and lessons learned that the engineering group, compliance engineering group has experienced over the years, and we just want to share with generator owners out there to help you look out for certain things. So that's my goal today. First thing I wanted to start with is engineering documentation requests. If you know you're going to be going through the NERC compliance program development process with a group like us, for example, as a consultant or whomever, however you're putting this together, recommendations that we have are to get out in front of that. So if you have your EPC contract, you have a relationship with your SCADA provider, your inverter manufacturer, transmission owner contacts, your other vendors that are going to have a role in the process, any of those folks that you have contracts with or agreements with, we highly recommend you get out in front of those data requests early and make sure that you know what documentation you're going to need from those folks, and you establish a reasonable timeline to get that to you so that you can have that analyzed and have your program developed in a timely manner. So happy to help identify what those sorts of things are. If there's ever any questions out there, but for example, those would be your IFC drawings for your substation, your field drawings, regardless of the resource type, manufacturer documentation, inverter settings, relay settings, like that that I'm referring to here. And you want to get a hold of that, and it should all be available typically 4 months prior to your anticipated COD and or when you think NERC registration might be triggered, with the exception of some commissioning documentation that takes place toward the end of your EPC's efforts. So that's the first recommendation. Might sound obvious, but be surprised that it could be something you're scrambling for if you don't ask for it on the front end from folks that you're dependent on there. Second thing I wanted to cover is trying to determine compliance with your, your inverter settings, your protective relay settings. So these are standards like PRC 24, PRC 25. When we go through the development and implementation of a NERC compliance program for a generator owner, we generate evidence for these standards for your program so that they're audit ready, and we demonstrate compliance with these various standards. And the standards that can result in non-compliant findings are the ones that I just mentioned, associated with relay settings and inverter settings. So you want to make sure that those are provided as early as possible, no less than 60 to 90 days outside of the anticipated date, nothing inside that, so that you have reasonable time to have those analyzed against the requirements of these standards, and you have the opportunity to correct any non-compliant findings, have conversations with the engineer of record, the EPC, the inverter manufacturer, whomever might be involved in those particular settings, to make sure that there's not any equipment limitations, and you can find a solution that's agreeable to all parties that also complies with the reliability standard requirements. You don't want to let those linger and try to analyze those too close to your anticipated date. Otherwise, you could delay your opportunity to register with NERC in a compliant manner at the time you're looking to do so. Other thing I wanted to mention that we see our generator owner clients face more and more, not necessarily NERC requirements fully in this slide here, but more of just regional requirement awareness. Some of it is trickling into NERC requirements more and more, but some regional entities, you could say ERCOT as an example, have more requirements of generator owners than the NERC standards might have built within them. So you want to be aware of those and make sure that you're consulting with those regions and making sure that you know all of the requirements that you're going to be subject to before you go through the process of designing your facility. And some of those will have some overlap with some of the NERC reliability standards. So if you know that, you can analyze certain settings, your protective settings like we just covered on the prior slide, for example, that are affiliated with PRC 24 that might also have overlap with the, let's say, IEEE 2800 requirements that ERCOT has adopted and expects generator owners to comply with. There's an opportunity to look through the lens of all of those requirements, NERC and other, and find a solution for settings that complies with all of the requirements for all the regulatory parties there. Also, a bit of future proofing recommendations. There's a couple reliability standards that we look at for generator owners, PRC2 and PRC12. For example, PRC2 is disturbance monitoring. It could be referred to some of the requirements within that standard or DME, SER, FR, DDR, all those acronyms related to fault recording and digital data recording. That's PRC2. We see that a fair amount as required in ERCOT from an equipment standpoint, but it doesn't necessarily mean that the transmission owner is going to require that out of the gate for your facility to comply with. But they may out of the gate, they may in the future, and so the equipment needs to be in place there. Similarly with remedial action schemes or RAS for PRC 12. There's certain regions, SCE, Southern California Edison, is one where they like a RAS, and you see that often designed in facilities in their area. So my point there is you see certain requirements more and more being adopted, and to design equipment that can comply with those requirements when you're going through your initial facility design is a good idea on the front end versus the transmission owner reassessing the applicability of those requirements in the future after you're operational, and potentially having to deal with challenges designing that into a facility that it wasn't designed for, facing equipment delays, things like that, that could potentially delay your ability to comply with it if it is required. So we have some generator owner clients that just have elected to design that on the front end in the event it is required, knowing that some of these things are being adopted more and more, and will likely be necessary in many more areas. So be aware of regional requirements is my recommendation there. I know John earlier today mentioned some modeling documentation readiness, and Kaylie just mentioned this on her prior set of slides, but one thing we validate for generator owners or compliance is the Mod 32 standard, and that's simply a collection of the base facility model files and the transmission owner's receipt and acceptance of those files. That occurs during the interconnection process, but sometimes there's different teams that your company might work with for asset management versus the interconnection team, perhaps, and there might be a delay in a year or two from when the interconnection agreement is established to when you're facing NERC compliance. So we often chase that down with a bit of a disconnect of where that documentation was housed. And so, I know Kaylie touched on proper housing of documentation post COD, but again, if you're designing a facility that is going to need to comply with NERC at some point, these are the types of things that, when it comes to modeling documentation, you'd be wise to gather all of that on an ongoing basis as different versions of that are developed throughout the process, knowing that once you're operational, you're going to need all of these base facility model files, and that's going to be your PSSE or your PSLF software that design those files, the PSCAD model files that your modeling vendor is going to need post-registration for the future modeling requirements of Mod 25, 26, 27. So you'll do yourself a favor to gather those and have those ready to support those mod testing requirements after you're operational. You may have a different modeling vendor that performs those at the interconnection stage versus post registration, for example. So that'll suit you to collect that and pass that through to yourself. The last topic I wanted to cover today is lessons learned with substation battery testing and maintenance. The substation batteries are put in place by your EPC when the substation is being constructed, and the first activity once that installation is complete is the initial commissioning of those batteries. Sometimes your substation may be constructed well in advance of the generation facility. Sometimes it's pretty back to back, but we do see instances where you might have a facility that's completed in late 2023, and the battery storage facility is constructed over many phases and isn't completed until late 2024. So you have a, let's say, 15-month gap in between the initial commissioning by the EPC before the facility is technically operational, and when the timer that Kaylie mentioned is started. And once the timer starts, now you have an obligation for a portion of PRC5 to have your batteries maintained within the first 4 months of COD or NERC registration. But that's the compliance with PRC5 to have it done within the first 4 months. But from a practical standpoint, you haven't really maintained the batteries perhaps for by the time the O&M performs the initial maintenance activity a month after the site is operational. It could be 16 or more months in that scenario, right? So there's a couple things we recommend you do to establish a proper baseline for maintenance of those batteries. And you can either, if you know it's going to be an extended period of time after the initial commissioning, you can create a datum of maintenance activities through a vendor, even pre-operation, that helps you create that baseline. Or the best solution we've seen and recommendation that works most often is the first activity to perform from the battery maintenance vendor through the O&M after you're operational, rather than perform the scope of the 4-month battery test, just go ahead and perform the 18-month battery test. The requirements of the standard is 4 months, 18 months, and then eventually you get to 6 years. So if you perform the 18-month every 18 months out of the gate, you can avoid the need to perform performance testing and potentially damage the batteries by putting more strain on them than necessary. So that's probably the most technical thing I wanted to represent today. We have a whole team of folks that can talk about that topic probably for hours in the background, but I think our next slide here is just thoughts, questions, and comments for either Kaylie or myself from this session this afternoon.
Great, thanks Ben, thanks Kaylie. So there is one question from Paolo, but what I'm going to do, I'm going to go ahead and unmute everybody. So now each of you have the option to unmute your microphone. So Paolo, would you like to unmute and ask your question?
Sure, can you guys hear me?
Yep.
Yes, we can.
Okay, yeah, so my question was just, we have some sites that are traditional power plants that have had solar installations built after the original site was built, and they're just put there to provide parasitic load for the plant. I'm not certain that all of them would meet the criteria of the 20 MVA or not, but if they were, would they be required to register as the GO category 2 if they are not, if their generation is never technically reaching the grid?
I think we would have to see and get a little bit more context on that. But my initial thought here would be yes, given that you do meet the criteria of a category 2. And some things you could consider is, is there a BES impact? And if you're unsure, you could always also reach out to the regional entities and consider looking at your operational boundaries. So is it fully integrated behind the meter? What's really going on and how's it connected?
Okay, thanks.
We hope to see you at our next webinar. Thanks again, everybody.
Thanks for joining us, folks.